I'm Rob from SmartBoat Innovations. Over the last few months, I've been hard at work coding new 2000 network integrations for our SmartBoat. It was a bit like delving into the matrix, trying to make sense of a world of complex binary data with zeros and ones. The 2000 network is a contemporary system based upon the CAN bus, similar to what's present in modern cars. Although this technology plays a crucial role in the marine sector, it is commonly found in many everyday applications outside of it. I've developed two new integrations, one for a wireless connection using an ESP32 called Smart2000 ESP, and one for a direct cable connection via the USB port called Smart2000 USB. So you can have your 2000 network backbone a few meters away from your Raspberry Pi, and you can collect all of this instrumentation data just using an ESP32 and this tiny CAN bus transceiver. This setup will wirelessly transmit your 2000 network data to the central Raspberry Pi. These boards are quite affordable, costing only a few dollars each. Additionally, this arrangement keeps your Raspberry Pi setup looking neat and uncluttered. Alternatively, you can choose a more direct cable connection using a CAN USB adapter. These adapters are available for about $25. Both these integrations can be installed via HACS. Here's a video that shows how to install HACS on your system. Designed with user friendliness in mind, these integrations feature a menu-driven interface for a hassle-free setup. Moreover, they are engineered to automatically generate Home Assistant entities based on the incoming 2000 network messages, simplifying your smart boating experience significantly. So even if you add new devices in the future, it will auto-discover these devices. After these integrations have set up the sensors, you can create a dashboard to display them as digital gauges. You can also use this sensor data for monitors and alerts to stay informed and proactive. Once you have this 2000 network data within Home Assistant, you can create amazing automations based on the created entities. You can combine as many as you like with the logic you desire. For me, this is more important than just having pretty digital gauges. I want the system to alert me by an alarm or text-to-speech when, for example, the engine temperatures have increased, or if the wind direction has changed outside our preset limits. Or you can configure a set of rules to when you need to reef your sails based on the sailing angle and the wind speed and whatever other parameters you would like. In this video, I will go through how to install, configure, and connect to and use both of these integrations. So let's get started. Here's a small 2000 network backbone I'm going to use for this demonstration. The center cable is the power, on the left is a depth sounder, and the right is a data cable. And the two ends of the backbone will have 120 ohm resistor terminal plugs. You can buy data cables that have a plug one end or the wires on the other end, or you can just buy a normal cable and you just chop off the plugs like I did and you expose the wires. You should have 5 wires, blue CAN low, white CAN high, red is the positive 12 volt, black is the negative ground, and then a shield, which is just a shield for the cable. Now before we use the data cable, it's good to test its health. Now with the power off of the 2000 network, we can test the resistance between the CAN low and the CAN high. And the resistance should be 60 ohms. So here we're 60 ohms, 60.5 ohms. If it's higher than 60 ohms, you're usually missing a terminal plug. And if it's lower than 60 ohms, you've probably got too many terminal plugs on there with 120 ohms of resistance. Now we turn the power on to the network, and now let's just test that the power is coming out okay, that we have a good power supply, and we get 13 volts. So our data cable is healthy. We have the right resistance for between the CAN high and the CAN low, and then the power cables are right. Sometimes these cables have different colors. Nearly always this is the standard. Black and white for power, blue is CAN low, and white is CAN high. Watch my ESP32 video about how to set up an ESP32 and load a base configuration ESP home. This ESP32 already has the base configuration loaded. Now I have it set up here on the breakout board with 5 DuPont cables. For this demo, I'll just use a USB cable to supply the 5 volt. But normally I use a 5 volt adapter, which it connects to the 5 volt and the ground pins of the breakout board. So here's the CAN transceiver. Now we connect these 5 wires. The first wire is the transmit wire, which is the white wire, which goes to pin 18. The next wire, the brown one, is the receive wire, which goes to pin 19. And then we have the ground, which goes to the ground terminal. And the orange is the positive 3.3 volt. So this CAN transceiver is powered from the ESP32. It has a very small power drain, so we can do that in this case. So now we connect the 2000 data cable to the CAN transceiver. The white cable goes to CAN high, and the blue cable goes to CAN low. And that's it. That's basically all the connections between the ESP32, the CAN transceiver, and the 2000 data cable. Normally I'll power the ESP32 with a 12 volt to 5 volt adapter such as this, a buck converter. So it takes in 12 volts and then puts out 5 volts. So you can, in this case, you can actually draw the power from the 2000 network data cable, or conversely just use a fused 12 volt supply from your ship's power. So here I'm in the Home Assistant in the settings page. Now I've created a ESP32 via the web tools like the normal way, so it's already provisioned. So here it is. Now let's have a look at the YAML. They keep on creating different types of YAML every time I run this, and it's got a lot more basic stuff. So what we need to do is get some YAML from my website and put it at the end here. While you're doing this, it's best that you don't have the 2000 network connected. Have it switched off, or don't have the white wire connected to the CAN transceiver, because it's sending a lot of data to the CAN transceiver and it's making the ESP32 quite busy. So it's better to have it calm while you update or install the new configuration, and then we'll turn on the 2000 network. Okay, so if you go to my website, smartboatinnovations.com, so homepage, go across to code, and then down on code you have in the Smart 2000 ESP. Alright, so this is the page here. So it's got the repository, video. So we need this bit of code here. There's two ways you can do a copy, or you can download it. You go down to the end here and paste it in. Now you don't have to touch any of this. This grabs the 2000 network, the CAN bus, and then formats it and sends it to Home Assistant as an entity, which the custom integration will then use. The only thing we need to do, so at the top here I've put a logger level to error. Just need to check that what do they have here? They have logger level to info. So let's just delete this and have logger level to error. Sometimes info just produces so much information that it slows the ESP32 down. Now I've put a sensor in here, which is a Wi-Fi signal sensor, because it's really important that the ESP32 has good Wi-Fi signal to the Raspberry Pi, because it's going to send a lot of data, the 2000 network data. It's going to send a lot of that quite fast, so it has to have a good signal. So I've made a sensor you can put onto your dashboard to see what the signal strength is, and then the rest you don't have to touch at all. These are the two pins 18, 19 that we connected on the ESP32, the CAN transceiver. So if you're going to put them to different pins, you need to change this, but the rest you just leave as is. And we'll just save, and let's go out. I always like to do a validate, good, and then install. We install it wirelessly. This will take some time, so I'll speed it up. Okay, so it's successfully compiled and uploaded the new configuration for the ESP32. So now let's go to HACS and install the custom integration. So we go to integrations, 3 dots in the top right hand corner, custom repositories. Now the repository name is in my website, so if you go back to the same web page, here's the GitHub page, just click on it and select the URL and go back and paste it in here. And then the category is integration, add. And then it's added up here. So you then have to click on it up here and that'll take you to the README page. And then you have to click on download in the bottom right hand corner. It's going to download it and it's done. So then we just search for the integration here and it says it's pending restart, which makes sense. So then we can restart. There's a number of ways to restart. I like developer tools and then restart. The Home Assistant. I'll just speed this up. Okay, it's started up. So now let's go to settings, devices and services. We need to add an integration and we have to find the Smart 2000 ESP one. So if you just type in 2000, it'll usually find it. Okay, so here's the configuration form. We need to put the device name. We need to give that ESP Home name. So we'll just go back to ESP Home, edit. You need this long name that you have here. I left it as a default name from the ESP tools, but usually I change this name before I add my YAML to something a bit more meaningful. But make sure you do it before you add the extra YAML and before you create the custom integration. Just change the name if you like by changing the host name. So we copy that, go back to settings, integration 1000. So at this stage, it's good to switch back on your 2000 network if you haven't already done it, because the way this works, it works on auto discovery, so it's not going to discover any entities if the network is not switched on. So in the top field, the ESP Home device name, we have to put exactly what we had. The PGNs to include, exclude, you can do this afterwards. At the moment, we'll just discover all the ones that I have on my test workbench, and then afterwards you can come back in here and put the ones you want to include or the ones you want to exclude. It doesn't only make sense to put into one field or the other. The 2000 network has a lot of devices, so a lot of these you're not going to really want to use in Home Assistant to display on the dashboard or have automations for. So for those ones, it's better to not include them or to exclude them, just to stop Home Assistant having to always refresh or populate those entities. Okay, so we just done it. If you press submit, and it's gone and it's found 4 PGNs. So we finish that. If you go to click on the integration and the 4 devices. For this workbench, I only have an EMR depth gauge, and that produces 4 PGNs, a distance log, environmental parameters, speed. So this is how you'll see one line per PGN, and then it's got the PGN number here under the model. If you go back to the web page of mine, there's a description of all the 2000 PGMs on the CANBoat GitHub page. The environmental parameters, the temperature is about 23 degrees, that's correct. Okay, so this is how it is for a simple test system. We'll now log into a friend of mine's boat who's already set this up, and he's got a much bigger 2000 network. So he's got 25 devices and 264 entities. We haven't done any PGN includes or excludes yet. So if you go into devices, you can see all the different devices or PGNs is discovered. I mean, some of these are useful, like wind data, water depth, vessel heading, speed. Some of these other ones, like the AIS ones, I'm not quite sure why would you want to use AIS in Home Assistant, but maybe there's some use case one day. Water depth is in 2.9 meters, and there's an offset as well. So look at the wind. In the 2000 network, most of the angles are in radians, so I've made the integration change them to become degrees. It's a bit more human. The same with temperature as well. The temperature usually comes in Kelvin. I've changed it to display Celsius and Fahrenheit. Now back on my small test network, let's just play around with the PGNs. So say for example I want to get rid of the distance log, which is 128.275. At the moment it has that information. So we go back, then we can go configure exclude, press submit. So the distance log, then it's going to show as unavailable. It will still stay here because these entities were created, but if you want to have a clean look and feel, once you identify which PGNs you want to keep, you can quite easily delete the integration and then start again, add it again. And when you start, you can put the PGN you want to include or the ones you want to exclude. So we're going to exclude 128, 275, and then submit. And it's only going to find three PGNs. And you'll get a much smaller list instead of having devices or entities which just show unavailable. So you can add these to a dashboard like you normally do. Click on add to dashboard, choose a dashboard, etc. I won't go through this because I've done it in all my previous videos and you know how to all do this. Okay, that's pretty much wraps up the first integration, which is the ESP one. So here is the Waveshare CAN USB adapter. The USB port on one end, the terminal port on the other for the CAN high and CAN low. It has a on-off for resistance. You can turn 120 ohms resistance on, and has a reset button. And the terminal block is detachable as well if you like. So the on-off, so you can actually use this as an N terminal and a data cable at the same time if you turn the 120 ohm resistance to on. But for this demonstration, I'll leave it off because we'll have sufficient ports on my 2000 backbone. So we only need two cables to connect here. The CAN low, which is the blue, we connect to the CAN low terminal. And the white cable, which is the CAN high, we connect to the CAN high terminal. The other three wires, the red, black, and the shield, you should trim, seal with electrical tape or heat shrink. This USB adapter also comes with a USB extension cable, so we don't have to plug the adapter straight into the Raspberry Pi, which is nice. We can have it at some distance away. So here's a Raspberry Pi. We're going to use one of the blue fast USB ports. We just plug it in, and that's basically all we have to do to connect the Raspberry Pi up to our 2000 network. So now let's set up the Smart 2000 USB integration. To do this, we need to firstly configure the USB adapter, because the way it comes from the factory, it's not quite set up for the 2000 network. So on my web page, if you go to code, and then down to the Smart 2000 USB, I have instructions how to set up this Waveshare USB adapter. Now, the easiest is to set up with a Windows device first. You set up the adapter once, and then we'll plug it into the Raspberry Pi, and we'll never have to reconfigure it unless you do a reset of the adapter. So you need to download this driver. I've already done this, so I'm not going to do it again, but just follow instructions that you have here. Download and install the driver. And then there's also a tool we need to download, which I've done. And then you have to then unzip it. So this is the tool here. So on the top left-hand corner, it should come up with a COM port. So you can do a refresh of the lists. So once you plugged it into your Windows, Windows will assign it a COM port. So in my case, it's COM4. So then we need to open it. The only things we need to change in the CAN configuration, the type. For the 2000 network, we need to use extended frame. And also the speed of the CAN bus is 250 kilobits per second. And then we leave everything else like that. None of these ticked. And you set and start. And if all goes well, you should see down here your 2000 network data. If it doesn't show here, the integration is not going to work. So you need to make sure that these settings are correct. So extended frame 250 kbps, just exit, and we can unplug it from our Windows and plug it into the Raspberry Pi. Then we need to install the HACS integration. So we've got integrations and the custom repositories, and the repository again. If you go back to my web page for the Smart 2000 USB, make sure it's the right one. Here's the GitHub page. Go to there, copy the URL, paste into here. Category is integration, and then there's add. It adds it up to here. Then we have to click on this part and download. Just make sure it's the right one. It's the USB one. So we'll download. Let me go back, search for it, just make sure it's here, and you'll say it's here, so it's pending restart. So we need to restart Available Tools, restart. I'll speed this up. So now let's add this integration. So devices and services, add integration, search for the 2001 SmartBoat 2000. Now here's the configuration page. The first field is the USB device name. It's just a logical name. You can give it whatever you like here. CAN 2000. The next field is the serial port name. If this is the first device that you plugged into USB, this is probably the default is correct. When you plug this USB adapter into the Raspberry Pi will allocate a serial port. And it'll start with the naming TTY USB 0, then TTY USB 1, etc, etc. If you really want to know which one it is and you're not quite sure, you can go to my web page under miscellaneous commands, and if you scroll down, I have a command ls/dev and piped into grep USB that you can run from the terminal, and we'll see which TTY USB ports have been assigned. But you can just do trial and error. It's either going to be USB 0 or 1, maybe 2 if you already have 2 USBs used. Now the baud rate, you leave at 2 million. It's quite a fast baud rate for serial, but you need that too because it's connected to a CAN bus. And the PGN Include and Exclude will leave. And then we click on submit. It's auto-discovered the same PGNs. So we have a look at the devices, and here we have exactly the same ones. Depth, temperature, and basically the integration works the same as it does for the ESP one as well. Thank you for joining me today in exploring the incredible world of smart boating. If you found this video helpful and informative, I would appreciate if you hit the like button below. And if you'd like to stay updated with more exciting content on boating and technology, consider subscribing to my channel by clicking the subscribe button. Your support means a lot and helps me create more valuable videos like this. Until next time, hasta luego.